Hired. This video is part of assignment 2 for the software security module in the MSc Cybersecurity program at SLIIT. In this assignment, we identified and fixed key vulnerabilities in our web-based application using security testing tools and implemented auth-based authentication to enhance overall security. We selected web-based platform application. It is meeting schedule application. It's designed to help students easily view and manage scheduled meeting notices. This application had been created by a group of students in the university before a few years. Originally developed using HTML, CSS, PHP, and JavaScript, the application first featured a traditional login system. Old version has been hosted in a live server. You can see now it. Now you can see the after fixing vulnerabilities and implement the Google Auth run code, and you can see the after implementation of those. Now you can see what are the vulnerabilities could be found from the system. There are 3 medium vulnerabilities and 3 low vulnerabilities. First, we found that application was missing a content security policy or CSP header without a CSP. The application is vulnerable to attacks like cross-site scripting and data injections. After that, we could found the application lacked protection against clickjacking attacks. Clickjacking tricks user into clicking hidden elements, potentially leading to unauthorized action or data leaks. After that, we found that the application was using an outdated JavaScript library, which can expose vulnerabilities such as cross-site scripting or code injection. Another one is cross-domain JavaScript source inclusion. This involved loading JavaScript from external third-party domains without restriction. Next one is server leaks version information. We discovered that the server was exposing its version through the server HTTP response header. This information can help attackers tailor their exploits. Finally, the application was missing the X-content type options header. Without it, browsers may snip the content incorrectly, which can lead to XSS attacks. We could fix 3 of these 6. According to that, we could fix missing anti-clickjacking header, vulnerability JS library, and cross-domain JavaScript source file inclusion. This is the report which after fixing vulnerabilities. Now let's see what we did to fix these vulnerabilities. Okay, now let's see what we did to mitigate missing anti-clickjacking header. Implement these header, this one, and this one, and this one we added to mitigate the missing anti-clickjacking header. And after that, fixing the vulnerable JavaScript library, we updated Bootstrap. We updated Bootstrap version. It's updated to version 5 point. Yes, we updated that Bootstrap version to 5 point. After updating, we could fix in that JavaScript light vulnerability. After that, we could fix the cross-domain JavaScript source file inclusion. We could fix adding this header by adding this header. After adding this header, we could fix that vulnerability also. And also we want to say this application hosted in Apache Tube server. Okay, now let's see how we updated this application with Google Auth 2.0 brand port. In that case, I like to introduce both roles: resource owner, university student, client MSA app, MSA resource server. We use the resource server for this Google Calendar to add the meetings. They are Google Calendars. Authorization server is the Google. Okay. The use protocol for can we discuss first is the MSA request from the student authorization to access service resources. When the student requests authorization, the MSA receives an authorization grant. MSA requests an access token from Google by presenting authorization of its own identity and the authorization grant. If the MSA identity is authenticated and the authorization grant is valid, Google issue an access token to MSA. Authorization is complete. MSA then requests the resources from Google Calendar. We use the resource in the Google Calendar and presents the access token for authentication. Upon the validation of the access token, Google Calendar serves as the resource to the MSA, which is to add reminder in the calendar. This is the process. Now let's see how we create the this project. We already created this project. You can see in Google Developer. This application, this project already created. So you can see app information, name, support email, app domain, authorized domain. Actually, this can be used only internal. Internal must mean rs.ac.lk domain. We added Google Calendar API from API library as resource. You can see we added auth client IDs, client default one, web client one, and here field redirection details, redirect URL. The redirect URI is anywhere the service will redirect. Afterward, they authorize MSA and therefore the handling part of authorization code or access token part of the MSA will be done by it. After the MSA meeting schedule application enumerated, client identifier and client secret will be produced by the service already produced. The client ID to identify MSA and to build authorization URLs that are presented to the student. String better a publicly exposed string is used by the service API. The client secret consumed to authenticate the identity of MSA app to the service API when it requests to access the rs.ac.lk and escape private between the MSA app and the app API. In the application, we added client ID and client secret here. In other ports, you can see uploaded source file. Okay, now let's see how to log in this application after update with Google Auth run bot. Sign in. I use my ra.html email. Okay, okay. In the application, you can see the port and I log out of the application. Okay, thank you very much.